Okay, we're now going to have a look at some characteristics of sex-linked inheritance and determining whether traits are sex-linked recessive or dominant, or perhaps they are Y-linked on a pedigree. Okay, so some characteristics that we're going to need to start to be able to identify when we're looking at different X-linked types of inheritance on pedigrees. If we're looking at an X-linked dominant trait, some characteristics that you need to be able to identify is if it's an X-linked dominant trait, any male that has this trait, so a male that is coloured in, a square that's coloured in, will pass this particular trait onto every single one of his daughters. So if there is a square coloured in, so for example this one here, every single daughter that that square produces, or every single daughter that that male produces, is also going to have this trait or be coloured in, which we can see is true here. If we were to look at an X-linked recessive trait, though, this time, if we are looking at a female or a mother with the trait, every single one of her sons is going to be affected because it is recessive. So that means the female would be X little r, and the only thing she can pass on to her son would be an X little r, and we know the son would have to inherit the Y chromosome from the dad. So the sons of an affected female, when we're looking at a recessive X-linked trait, will always be affected. So for example, we have an affected female down here, and we can see that every single one of her sons has the trait. Obviously, there are other features that you can be looking for X-linked dominant and X-linked recessive traits. Please feel free to read through those yourselves, and if you've got any questions, get in contact with your teacher. So we're first going to have a look at an X-linked dominant trait. This particular trait is known as rickets, and it causes a vitamin D deficiency. We have been told that the X-linked dominant allele to represent rickets is represented by X capital R. So our first task is to list all possible phenotypes and genotypes for males and females in relation to this disease. So if we are looking at females, we can have affected females, so the circles that are coloured in, and if they're affected, they could have X capital R, or they could be X capital R, X little r, and be heterozygous. We can have unaffected females. If they're unaffected, they won't be coloured in, and they would have X lowercase r, X lowercase r. If they are a male and affected, they're going to have X capital R, Y. Remember, males only have one X chromosome. If they're males that are unaffected, they're going to have X little r, Y. So they're the possible genotypes that individuals in this pedigree could have. We haven't been asked to work them all out because that would take us all day, but if you guys want to have a go, feel free to have a go, and then check your answers with your teacher. The second part of the question on the screen, though, is asking us to identify what is the genotype of all the affected females in this pedigree. So that's assuming that all of the affected females have the same genotype. And how can we know this with 100% certainty? So if I look right now at a female, if I just pick one at random, so I'm going to pick individual 6 in generation 4. So this female is affected, and I identified before that an affected female could be X capital R, or they could be X capital R, X lowercase r. If I look at this female's parents, her father is affected, but her mother is not. So this father would have had X capital R, Y, and he would have passed his X capital R onto his daughter. So she's got one X capital R from her father. The mother, on the other hand, though, is unaffected. So X lowercase r, X lowercase r. It doesn't matter which one, but the mother is going to pass an X little r onto this daughter here, which means that her genotype is going to be X capital R, X little r. And if I have a quick look through this pedigree at all of the females that are coloured in, so all the circles that are coloured in that are affected, every single female only has one affected parent, which means that that affected parent is passing on the X capital R to that daughter, but the unaffected parent, whether it's the dad or the mum, the unaffected parent is always passing on the X little r, making all of those daughters that are affected heterozygous for this trait. Okay, let's now have a look at an example of an X-linked recessive disorder. So we're looking at haemophilia. We covered this when we looked at the circulatory system back in term 1. So haemophilia is a blood clotting disorder, and it's actually caused by an X-linked recessive allele. So our allele for this particular trait will be the X, meaning it's on the X chromosome with a lowercase r. So first part of this question, list all possible phenotypes and genotypes for the males and females in relation to this disease. So first of all, if we're looking at affected males and females, so the affected ones, remember, are shaded in. So an affected female must have 2 copies of the recessive allele, so X little r, and a male who is affected obviously only has 1 copy of the X chromosome, so X little r, and the Y chromosome. The unaffected individuals, so an unaffected female, so the ones that are not coloured in, they could actually have 2 possible genotypes. So X capital R, X capital R, so the homozygous dominant, or they might have X capital R, X lowercase r, being the heterozygous individuals. For the male, an unaffected male can only have 1 possible genotype, and that would be X capital R, Y. So let's just use that information to fill out some of these genotypes on the screen here. So the female in the first generation will be X lowercase r, and the male will be X capital R, Y. If we look down to the second generation, we've got a son who is affected, so X lowercase r, Y. A female that's unaffected, so they would have inherited the X capital R from their father, but an X lowercase r from the mother. This affected son, X capital R from the mum and the Y from the dad. And this female here would have been X capital R from the dad, X lowercase r from the mum. Okay, and we can kind of fill out the rest of the pedigree like that. Which sort of leads to our next question. Can we work out the genotype of all the unaffected females with 100% certainty? And the answer is pretty simple for an X-linked recessive disorder. Most of the time we can't. And the reason we can't is because the unaffected females have the possibility to have both of these genotypes. And sometimes we're not provided with enough information in a pedigree to be able to make that call accurately. So for example, one that we know we're not going to be able to determine their genotype with 100% certainty is probably this female here. Okay, so there's not enough information in the pedigree here to determine whether she's going to be the homozygous dominant, X capital R, or X capital R, X lowercase r, the heterozygous. The same with these children over here. So these 2 females and this female here, we probably don't have enough information, although we could work out the genotypes of the parents. So this father would be X capital R, Y. I'm not certain, or we can't determine with certainty, that yes, they would have got an X capital R each from dad, because that's all he can pass on to his daughters. But we don't know whether they got an X capital R from mum or an X lowercase r from mum. So we don't know what that second allele is with a 100% certainty for these females here.